and a bunch of fiddling, we got to work. Okay, quick show of hands. How many people have played with Firebase on Android, but not the real-time database part? Anybody? One? Oh, I didn't know I was such an early adopter. Okay, so today I want to talk about Firebase notifications. My name is Eric. I work here as an Android developer. Recently, I built an app for Shopify called Entrepreneur's Digest. It is an app to read our company blog. The team that I joined is a growth and marketing team, so they were very interested in doing experimental apps, things that we could test ideas about growth and user acquisition. So this is a couple of screenshots of the app. It's very basic. It's basically a glorified RSS reader. You can see the articles. They can be cached offline. They load quickly because they parse AMP. And we use push notifications to tell people when new articles are published, so 1 or 2 a day. So it was a great opportunity on a brand new project to try out libraries and technologies. I wanted to use Firebase. If you saw the announcements at I/O this year, Firebase is now this giant mobile platform that incorporates a lot of the disparate features and technologies that they had before, as well as the real-time database that they acquired from the original Firebase company. I've been using push notifications off and on since the days of C2DM, when it was very, a slog to use all this manual stuff that you had to do. Now, if you look on this chart, that sort of an overview of all the Firebase technologies, you see something under the develop section called cloud messaging, and you also see under the grow section, the red segment there called notifications. Now, they sound like they're talking about the same thing. Are they similar? Are they different? Why are there 2 different, but perhaps similar things? Let's look into that. Cloud messaging versus notifications. So Firebase cloud messaging really, and this is how Google describes it, is just the old Google cloud messaging under the Firebase brand. The feature set is pretty much the same. It's got the API endpoints are pretty much the same, except instead of like gcm.google, it's now fcm. We'll get a bit more into it, but you can kind of think of it as not being any different. GCM is still supported for the foreseeable future. There's a huge installed base of people using it, but under the hood, it's exactly the same infrastructure. Notifications, though, is, despite its confusing name, is a brand new service meant as a growth tool. So if you've used GCM before, you know that it's a service that can reliably deliver messages to devices, both downstream and upstream. You optionally can run an application survey. You don't actually need one. You can just communicate it through even a command line client if you don't need to manage all your devices. And cloud messaging comes with a bunch of client SDKs for Android, iOS, and you can even use it to talk to desktop Chrome browsers. Notifications has a really nice console. This is the first time, I think, in my experience that Google has offered some sort of GUI for sending notifications. If you're a developer, it's probably no problem for you to make a REST call, but for non-technical people to be able to send notifications to your user base through a console is an awesome feature, especially since it has a lot of the power that FCM gives you, but it's designed to send engagement messages. So you can actually send to segments of your user base, like a certain country, the language that they run, or the app version of your phone, very simply, and you can, best of all, you can actually track the performance of those notifications. You can look at the open rates, whether they led to a particular conversion or not. So here is what you need to do to start integrating on Android. You add this line triple.gradle. And this is also the end of your integration. This is all you need to do to get notifications in your app. Whether you're using cloud messaging or notifications, you can't get much simpler than this, but clearly there's something under the hood. So let's have a quick look at what you get when you add that line. If you've done GCM before, you know you had to create this permission so that only your app server can send to your app. All that's handled for you through the magic of manifest merging now. Before you had to register for this token and optionally send it to your app server if you're using one. And every so often the GCM server will give you a response and say it's out of date and you have to refresh. All that's done for you now. You had to create a broadcast receiver to actually get those pushes. Default one is registered for you. And also, when you get a message, you need to parse it out the body, the title, all that stuff, and to display it in the notification tray. That is done for you. And what GCM called PubSub is now also called topic management. There is the subscription with that can be done asynchronously, and it will retry for you in the background, also for free. And best of all, automatically collected analytics. Amazing new product, right? Here's a look at the console. You can see that there's at the top there's this message text that's a mandatory field, that's the body of the message. And there's a bunch of optional things. They have a nice feature where if you're sending notifications and your user base is distributed worldwide, you can say only send this at 9 a.m. in my user's local time zone. So FCM will handle the deferred delivery of that so that you don't wake somebody up in the middle of the night on the other side of the world. Underneath there where it says target, you can also send to segments, such like I mentioned before, users in certain countries or a certain demographic. And there's a bunch of advanced features too, like you can set the priority, the expiration of the message. If you're a sports app, your sports score probably is only good until, well, no later than the end of the game, but until the next score update or something like that. And after you create these notifications, you get funnel analysis too. So every notification you send from the console, you can click on it, and it gives you a report like this. This is just a sample one, there's only one, but you can see the first event there is a notification was sent, and then it was clicked, and then optionally you define a conversion. So you can see if specific messages, maybe you're trying out different wording, or you're trying out different styles of notifications, whether they perform better than others. The feature set is amazing so far for that one line of adding into your code. But if you've ever built any notifications, you know that sometimes you want to do something different. Perhaps your app doesn't use the same icon for every notification it sends out. Perhaps you want to create a summary if you send a lot of notifications, you're some sort of messaging app, you don't want to clutter the user's notification tray with too many notifications. What if you want to send a notification not to display to the user, but you want them to, it's an indication to your client that you want it to sync with the server because it has some new data for the client. Can you do that? And on top of all this, if I do all these things, do I still get those analytics, and can I still do my funnel analysis? So we saw that the console had some customization. You obviously can change the message text, and you can send to different segments, and I mentioned you can also do advanced options like priority and sound or predefined icon. But it turns out there are some things you can't set. You can't set a collapse key, so you're not able to just choose whether this message will supersede a previous one, and a bunch of other things. So to understand more about how the default behavior on Firebase notifications works, we have to look and understand the two types of messages that FCM deals with. So the first kind is a notification message. This is, you know it's a notification message because the body of the payload here has a notification key. And in this object, the keys are predefined. You can specify a body and a title. And if your app that is integrated Firebase gets one of these messages in the background, it will automatically display the title and the body for you. You don't have to do anything. If your app is in the foreground, it will try to call a callback that you've sent. This is all by default. And the console, it turns out, only sends notification messages. And that's because the form field that you have to send there from the console, the field for the message text is mandatory, and it maps to the body key of this notification object. The other kind of message that FCM deals with is a data message. That looks very similar, except instead of a notification object, you now have a data one. The difference, though, is that a data message, you can have any sort of key value pairs that you want. They're completely arbitrary, and your app, though, has to decide how to handle that. There is no default processing for you when you receive this kind of message. The only way to send this type of message is through the Firebase cloud messaging API. You cannot send this type of message from the console. If you've played around with the console, if you open up the advanced options, you'll see that you can set custom key value pairs. And if you're monitoring on the wire a packet sniffer or something, you'll see that they actually go into this data object, but it also creates a notification object as well. And when you have both the notification and the data sections, it's treated as a notification. It will display it and then give you the data separately. So here's a summary of the behavior. You can see that when you're in the foreground, nothing happens by default except calling this callback. If you're in the background, if you get a notification message, it's automatically created and posted to the notification tray. And if you're in the background, if it's a data message in the background, your callback will be called. This distinction between notification and data is probably the biggest source of confusion that I've found in a lot of forum posts and Stack Overflow posts that I've been reading. Even though this notification versus data distinction existed in GCN, and that's been around for a couple of years. So it's important to understand if you're debugging notifications, what's happening is to look at the kind of message you're sending and whether your app is in the foreground or background. So by looking at this table, it's clear that if you want full control of everything that happens, you need to send data messages because nothing happens for you by default. Your callback gets called and then you deal with it. So that was my next step, is to start creating data messages and sending them. But I discovered something. I didn't see any of the analytics in the console anymore when I was receiving those messages. And because no analytics were tracked, I didn't get the funnel analysis either. So this is bad news, because that was exactly why I wanted this. I wanted as much of the built-in stuff as possible. So the question I asked myself is it possible to get the best of both worlds? Can I get the nice, friendly console and the analytics that I get from the Firebase notifications feature, but have the raw power and the flexibility of cloud messaging and be able to create the notifications my way and how I wanted them? So for the rest of this talk, I'm going to talk about what I did to achieve some of these goals and also some of the things I wasn't able to do. So the first thing is grouping your notifications. If you have Gmail on your phone, you've probably seen when you get more than one notification per message, they get all grouped together. And this is just to prevent you from getting, most people have more than one email account, and if you've got separate notification for each one, it would quickly fill up your notification bar. In the recent versions of Android, these summary notifications can actually be expanded, so you can show a bit more. I think it's called big text style, the ones that can expand. And this is the best practice. Again, to avoid frustrating the user to have too many notifications. The summary, it's your responsibility when you're creating the summary to put in a meaningful message. In this case, it says 3 new messages. To indicate to Android that several messages are related, when you're creating your notification with this builder, the one that I've highlighted very in the gray chevrons there, set group. That's all you have to do. You just give it a string that represents the group. If you're a messaging app, it could be the account name. If you're some other kind of app, it could just be the type of message it is. And when you do that, Android will know that these are related notifications and to group them. To create the summary, you link the summary notification with your group by also setting the same group value on it, but you also set a flag called set group summary. So this is, a summary notification is a separate notification that you have to create and post, and Android will just do the right thing. So on a Lollipop phone, you will see this summary notification, but none of your other ones. Even though you posted each of those ones individually, you'll see the summary and it will expand. On a different device, you would see something like this. So on Wear devices, you don't want to show the summary because you don't have enough room to really show that information. So what happens with group notifications, they're shown as a stack. And a stack, you can kind of flip through them and look at each one individually if you want to. Again, if you're using Notification Compat Builder, this behavior you get for free. So hopefully everybody's been using the the compat builder, not the platform version. And especially now that Nougat, where there's been a huge overhaul of the notification system, this is what group notifications look like now. It looks the same on the top when it's collapsed. It looks like a summary. But when you expand them, you can actually operate on each individual notification in that group. And so that also has implications when you're writing your summary, because the user now, before, when the summary was shown, they couldn't do anything with individual notifications. But now, if you swipe away one of those individual ones, it's your job to update the summary to now say that there's only 2. So the next thing I want to look at is when to show a notification. There could be a couple reasons why you don't want to show it right away when you're receiving a notification. If you have some sort of do not disturb setting in your app, where you want the user to be able to configure that, that's a good reason. It reduces the complexity on the server just sends it, and the client decides whether to show it to the user or not. And I mentioned before a sent to sync message, so a message where it's not really a message for the user, it's actually a message to the app to say, please sync the data and then do something. So from the perspective of this blog app that I wrote, the messages we were sending are ones we want to show the user. But I didn't want to immediately display that. I wanted to sync with the server, so I got all the metadata about that. So when they tapped on it, they would immediately be shown the content. They wouldn't have to do a fetch at that point. So if you think about this syncing business and the incredible performance of Firebase, I think they say that they're delivering 150 billion messages a day, 95% of them in under 250 milliseconds. When you send that push, your users are all going to get it at the same time. And if they all turn around and sync with your server, you're not in for a good time. You need to make sure that your server doesn't get overwhelmed. And so there's a couple things you probably can think of right now is that you can randomize the time before you start to sync. And also to be a good app citizen, you want to only do the sync when the user is actually actively using your phone or the radio is already on, and then you kind of piggyback on that open network connection. To do that kind of background sync that respects the battery and the batching, fortunately, since I think API 21 Lollipop, there's been a job scheduler API. I don't know if anybody's worked with that directly. I haven't because, we, like a lot of us, we still have to support the open platforms. So there's been 2 implementations that sort of wrap the functionality given by Job Scheduler, but is backwards compatible with much older phones. So one is Firebase Job Dispatcher. If you go to Google's training guide on doing scheduling background work, they'll recommend you do this. I personally am not recommending it because it hasn't been released in any sort of standard way. It only exists as a GitHub source code project, and their installation instructions are compile this yourself, take that AAR and drop it in your project and reference it. They don't have it in any sort of Maven artifact repository yet. Fortunately, the old GCM network manager is still around, and it works perfectly fine with Firebase. It's built on top of Play services, which, if you're targeting phones that don't have it, that might be something for you to consider. And it's also not getting any new feature development. Google is pushing people to use Job Dispatcher, but at the current time, we're kind of in this gray or in-between period where they haven't officially launched or released Job Dispatcher, but GCM is sort of on its way out. When you use the network manager or the job scheduler API, the kind of job that you define, you actually, in the job attributes, you say, this is a job that needs any kind of network. Or this is a job, because I know I'm going to sync a lot of data, I want it on a non-paid or whatever, unmetered connection. And you also can define, this is the minimum amount of time before it should start, and this is the maximum amount of time that I'm willing to wait. So the more lenient or the more flexible you are, the better that the job scheduler can try to batch together jobs from across different apps in the system and defer them. So the idea is that if one app has an urgent request to make, because I don't know, it's an incoming call or it's an emergency or something, other apps that were waiting can suddenly say, oh, the radio's already active, the network's alive, and then the scheduler say, okay, do these other jobs as well. So that last link there's a ton of reading about the various APIs you can do for background syncing. So let's look at how you can integrate GCM Network Manager into your project. It lives, that class lives as a component of this Play service of GCM. Despite its name, it's totally safe to use with FCM. In your manifest, you need to add a messaging service. This is where the onMessageReceive callback that we saw in that table. So you need to implement your own extension of this so that you have a place that gets called, where that callback gets called. And the other thing you need to do is to define a service that implements or responds to this action task ready. It'll be an extension of GCM task service. This is what the network manager will call when your job is ready to run. So you implement your job handling logic in here. The GCM network manager will take care of figuring out when the job is ready to run. This is what the main method of, I think the heading is wrong here. I think this is actually the Firebase, or my background service. This is where Firebase Cloud Messaging will call when you get a notification. In this case, I've parsed, or pseudocode here to parse that incoming message and grab the article ID, which is the unique identifier I have on my piece of data. And I call another method in this class called the sync helper, called schedule article fetch. And the way that I jitter or stagger that start sync time, or the minimum sync time, is just by randomizing a value I have called sync min. So that first argument there is the minimum start time, and the second argument is the maximum time you're willing to wait. Now I've glossed over, but I've alluded to it in this comment, is that this method is called when you sent yourself, or your server sent you a notification. So you want to remember this somehow. So it's either in memory, or you persist this information so that later, when your sync is done, you can go and post that notification to the user. So it's an exercise for you to figure out what you want to do there. Back to that helper, when you're scheduling that, so the meat of that method would be to create a one-off task that specifies that I do need the network. That's a separate part network method in the builder. The execution window, again, is that min start time and the max start time. And once you create that task object, you just pass it to the GCM network manager, and you're done. Yeah, I think I have these headings backwards. This is actually a GCM task service. So when that job is ready, the callback you'll get in your service is on run task, and you've been previously encoded any parameters you need for your job. So in the case of my article fetch, it was the most recent article that I already had. I tell that to the server so it can give me just the delta of what's newer. And then you make your call to your remote service. When you're done, use whatever method you have when you're communicating between your components, like an event bus. At that point is also where you would go back to the list of the pending notifications you were supposed to create, and at this point now if you've synced with your server, you can create those notifications and put them in the notification tray. Okay, so now we've talked about how to customize notifications, follow best practices with summaries, as well as how to implement a send to sync using the network manager. Let's look at analytics. So Firebase notifications out of the box, when you were sending those messages through the console, it recorded these 4 analytic events for you. One when you get one in the foreground, one when you get one in the background, one when the user taps on it, and one when the user swipes it away. These are all reserved names, meaning that you can't call the analytics log event method with these same names. So we're going to have to use our own names, fine. And the built-in funnel analysis only understands those reserved names, so we don't get that either, so we're going to have to do our own funnels. So I want to talk briefly about how to implement all 4 of these, so you can kind of track the same analytics and try to get the same analysis. So first thing we need to do is detect whether your app is in the foreground or background. There's a lot of ways to do this. Some are easier than others. Some are more accurate, depending on your definition of accuracy. We want to know whether you're in the foreground or background, not just to record the analytics, but because you want to know, you might want to do something different. If your user is actively looking at your app, you probably don't want to show them a notification. That's a bit annoying. You just want to update your data and maybe do a toast or something and just tell them that we have the latest data. But if they're in the background, your app is not the active one. They will want to know, that some new data is available for them. So these are two links for two different techniques for detecting whether you're in the foreground or background. Mark Murphy, the Commonsware guy, has an old post about ordered broadcast, which some of the Firebase engineers have said, they've alluded that this is how they do it in the built-in the notifications library. And another technique from Philippe Bro, who's a developer in Montreal, uses the activity lifecycle callbacks, as well as this callback in the application class that Android calls once in a while. But anytime you switch away from your app, it tells your app, okay, you're not being shown anymore, you should trim your memory, you should purge your cache or something like that. So that's exactly what we need. In the application subclass where you register those callbacks, you would do all the bookkeeping and keep a boolean. So assume we've done that, and now we have a boolean that we can call at any time on your application class, whether you're in the foreground or background. It's really easy to just record these events. Anytime that you get a notification, you just get the current state of background and just log that event. Fairly straightforward. The other thing you might want to record is you can pluck out some of the details from that notification. So if it's a particular item ID that the notification was for, you might want to record that with the analytic event also. When you open a notification, this is a wall of code, but if you've created any notifications that need some sort of custom handling when you open them, you're familiar with the very last line on the slide there, the content intent. The code above is just creating a standard content intent. The one thing I want to point out is on the second line there, I'm using an intent service as the what will get notified when the notification is tapped. I like using an intent service because it allows me to do any background work if I need to. If you use a broadcast receiver, that's not really meant for you to run anything long running, especially a network operation. So if you need to do that, an intent service is the way to go. For simplicity, I've defined a single service called Notification Action Service that handles both the open and the delete events when you either tap or swipe on the notification. It's fairly straightforward. And the way to distinguish is that you just pass the action. So that notification service, when it's called, on handle intent is called, you just switch on that action and say, oh, the user tapped on this notification, or oh, the user tapped or swiped it to delete. And so implementing the notification dismissed event is analogous. Instead of registering the content intent, you register a delete intent. You would pass a different action called notification swiped or something. So that's analytic events. Firebase also has the concept of user properties. So user properties are attributes about individual users, where events are about actions that have happened or have been taken. So some things that are already collected for you by Firebase include the app version, the age group, the gender, and those come from this Android advertising ID that's sort of secretly sent. It's used to I don't know, track all your behavior or something. They kind of gloss over exactly how that works, but they have an answered question about how that happens. You can also record information that will be useful for notifications. So the ones that I was thinking of recording are if you have a settings screen to enable or disable notifications, which you really should, you might want to track that, what the state of that setting is. And also, Android now allows you to block notifications completely from the app. So regardless of whether you have a setting or not, your user can just go tap, block all notifications, and the user will never see them. If you also use another Firebase feature called Remote Configure or something like Mixpanel to do experiments, you can also track the experiment variant in that user property. One caveat about user properties, you must register any property that you're recording in the Firebase console if you want to report on that, if you want to filter on that later. So back to that notification settings activity. It's a best practice to have one so the user can turn them on or off. An important thing, which I actually see a lot of apps not doing still, is to declare that settings activity with this category called notification preferences. When you do that, you are providing the user with a shortcut to get to your settings activity. So if you long press on a notification, you'll get a little gear icon that will take them directly. So if they have no idea where this notification came from, and you've defined this, you long press on it and you'll get to your settings activity. Also, in I think Lollipop and Higher, there's now a system settings screen called App Notifications. From there, all applications that have registered a settings activity and sort of a one-page list of the settings activities for every app on your device. Fairly simple to track it. Once you have a settings activity and you've implemented it with a switch or something like that, you can just do something like this. When the shared preference changes, you set the user property to, you give it a name and you just say whether it's true or false. User properties have to be strings, which is why I have to jump through that boolean to string business there. Now, I mentioned that on newer versions of Android, you can block all notifications. It's a stretch metaphor. It's like a force field around the user that notifications can't come to them. To find out the value of that, there is a fairly recent method a method was added fairly recently to the support library in 24.00 and higher called rNotificationsEnabled. So very easy way to get the value of that. One gotcha about that is that if you're running or calling this method on an API 18 or earlier, this method will always return true. I don't think there was actually an OS provided way to I've seen this setting on a phone as old as API 16, but I guess there was never a OS exposed way to read that value. And so if you want, you can record that user property. Now, why do I want to get both the system notification setting as well as my in-app one? That brings us to talking about audiences. In the Firebase console for analytics, you can only filter by one property at a time. So audiences are sort of the way for you to combine user properties, events, and their parameters to segment your users. So here's a capture from what it looks like on the console to define an audience. A specific one I wanted to highlight is if you think about your app setting for whether the user says they want to enable or disable notifications, it doesn't matter what they hit or what they flip if they've completely blocked your notifications. So in order to capture all the users that have disabled notifications, you need this simple Boolean expression that all users who have turned off their system notifications or users who have disabled the notification setting in your app. And conversely, for notifications enabled, it's the users that have enabled them at the system level as well as enabled them in your app. So you can define two audiences this way. Once you have these audiences, you can filter by them. So you can see I've actually set, it's an audience, it's a different audience at the top there. But this is where you would do it. Anytime you're digging down, when you're looking at the dashboard or like specific events, you can filter by that audience. This screen is showing the funnel report. So this is separate from if you're using Firebase notifications, when you click on any notification sent, you get a funnel report. This is an arbitrary funnel that you can define on any kind of event. And it's the only place we can go to recreate sort of that funnel analysis behavior. So you can see what I've done is I've called my events X notification receive. I just prepended the built-in ones with X. I've defined a funnel that the first event is X notification receive followed by X notification open. And this gives me a report, and I've also filtered it by this audience with an experiment that I was running on the body of the message. This gives me a report on the performance of this notification. However, it's not quite the same as a report that you get in the notifications console, because this is telling me across my whole app how many receive events were triggered, followed by how many opens. This is across all notifications that I've ever sent, and not the individual ones. So even though I recorded my item ID, when I say, article number 123 was published, I'm going to tag that onto the analytic event. and I want to know who received that and who opened it. This funnel is not taking that into consideration. So we run up against one of the biggest limits of Firebase analytics at the moment, is that those analytic event parameters are not available to you for reporting. The only place they even make an appearance in Firebase is when you're defining audiences. But it's not practical for you to, if you're sending out, half a dozen messages a day, it's not practical for you to define a new audience for every, combination of article ID or experiment that you're doing. So we actually aren't able to get the same funnel analysis that we had when you were using Firebase notifications. I don't know, is this a deal breaker for people? I mean, is it time to abandon ship and go back to Google Analytics or a competing analytics platform? I don't know, it depends on your needs. If you're happy with, I guess, the implementation you have now, a light or some possible good news in the future. From looking at the forums, Google and Firebase are well aware of this. It's one of the most frequently requested items for them to provide sort of that level of granularity in the analytics reporting. And right now, an alternative which I'd like to investigate at some point soon is to take all your analytics data from Firebase, including the events and the parameters, and stream them to BigQuery, which is Google's massive sort of cloud analysis, big data set query thing. That has a few caveats. One is that you only get the data as soon as it only starts streaming when you enable it, so you don't get all your old data. And the second is that it costs money, so it's not free. Now, unless you're building an app that's used by millions of people, you get a terabyte of data analysis free per month, so it depends on your app. The very final part of this talk, which I haven't really mentioned so far, is how to actually send notifications to FCM. So FCM is this giant mothership that has all this resources to send to your clients. How do you actually send that request? I mentioned that I wasn't using an application server. In my case, I don't need to individually send messages to users. They all get the same one. That there's a new article and here's the title of the article. What I ended up using was topic messaging. And normally topic messaging is, you might define a topic for sports-related news articles. You might define a topic for, I don't know, home decorating or something. If you're a sports team, you could have one for every, or a sports app, you can have one for every sports team, one for every game, and then users subscribe to a particular game they're interested in, or a particular team they're interested in, a particular date, and you only send messages to people subscribed to those topics. So it's a standard pub-sub kind of model. In my case, I used it to avoid having to keep track of all these registration IDs by creating a topic called all new articles that devices all subscribe to anytime they're the first launch of the app. And then to send to them, I'm literally running this shell script from my command line. You can see that I've created a data message there. And in the to field, I've set the topic that I want to send to, and I pass it the server key that you can look up from the console, and that's it. That'll send the message to all the devices that have subscribed to that topic. That's pretty much it. So to recap, Firebase Notifications is a really cool console that covers the basic use cases, perhaps for marketing and re-engagement. But for anything beyond the most basic messages, you're going to have to get to know Firebase Cloud Messaging. It means that the code complexity, you're not writing any less code than you did when you were using GCM, unfortunately, and perhaps a little bit more, because if you want to integrate with all these analytics. And while you can get some of the analytics back with a custom implementation, you're not getting everything that the Firebase Notifications console is giving you. So that's it.